Now we're going to take a look at the Generalized Bedrock Geology of New York State map found on page 3 of your reference table. Now this map of New York State shows us many things, so many that we will revisit it several times throughout the course. For right now, I'd like to focus on several major features and locations found in the state. Now it's very important to be able to recognize New York State on a United States map or just a map of the northeastern part of the United States. So focus on the shape, which is triangular in New York State. We can point out, in addition to the general shape, several major lakes. So for example, we've got two of the Great Lakes, Lake Erie and Lake Ontario, bordering more of the western and northwestern parts of the state. We have the Finger Lakes, which we will talk a whole lot more about when we talk about glacial features in New York State. They were formed by glacial action. We see Lake Champlain, okay, over here. So several major lakes. In addition, we find several major rivers. For example, we've got the Mohawk tributary into the Hudson River. We've got the Susquehanna and the Delaware rivers, Lake Champlain up towards the northern part of the state, Niagara River, and the Genesee River. Cities, let's get rid of some of these states to begin with. I should say some of these waterways to begin with. In terms of cities, well, you'll come to recognize more and more as we go on, but we've got Albany, we've got Buffalo, Watertown, Syracuse, Binghamton, all of these different parts of the state, Messina, you will come to recognize more and more, but it really takes practice and patience working with the map in order to see all of those different things. Now, since this is the first time that we are working with this map, I guess we should look at the basics of good map making, which means that there is a compass directional found on this map. It's going to be in the lower right-hand corner. Okay, we've got it right here. Happens to be right next to the distance scale. So we've got distance measured out both in miles and kilometers. Again, of course, just be sure if you are measuring, you know what units you want to measure in. There is a key to the symbols that are used in terms of shading on this map. The key is down here in the lower left-hand corner, which gives us what the title of the map talks about, Bedrock Geology. It also gives us a key to the different geologic periods that those bedrocks were laid down. Okay, that actually we will take a look at a later time. In addition to kind of the general focus of getting our bearings straight in this map, what I'd like to spend some time on today is latitude and longitude, because that's a skill that we learn early on and we can apply it to this map. So, some basics on latitude and longitude. Now remember, latitude lines are those imaginary lines that run east to west, but they measure north or south of the equator. Okay. For us on this New York State map, all of our latitude values are those that are in the 40 some odd degree marks. Okay, and you will notice they are lines that are going to, imaginary lines that will look like they run east to west. So we kind of see them measured, okay, on both sides of the map. So we've got the 41 degrees all the way towards the southern part of the state, going up to 45 degrees towards the northern part of the state. And of course, since we are all north of the equator, these would be 40 some odd degrees north. our longitude values, which are the imaginary lines that run from pole to pole. They measure degrees east or west of the prime meridian. All of our longitude values are going to be in the 70 some odd degrees. So you'll see the 73, here's 74, 75, 76, 77, 78, 79. Okay? So you see those, and again, they give you the tick marks on both ends of the state so you can kind of orient yourself better. Now granted, I would say in looking at this kind of map, it takes a little bit of practice. So how about as we get our bearings, we take a look at another view of the map, one that I've already drawn in, those imaginary latitude and longitude lines. And when you look at it this way, you say to yourself, yeah, it looks so much more like a map that I'm familiar with working with. Of course, you're not going to have the lines drawn on your reference table in a test, in a quiz, in the Regents, but you can always lay a straight edge or the edge of your Scantron down on the map to kind of create that same visual look to help orient yourself. Now, drawn this way, there's something else that we need to see. We need to see that, for example, if I were looking at the value of, right here, 42 degrees north latitude, okay, and I go the next full degree north, which is 43 degrees north, you'll notice there's quite a bit of distance, of space in between. So how do we account for what's going on in this area in between? Well, we need a unit that is smaller than a full degree. And what we have is a full degree being divided into the next smaller unit, which is called a minute. And there are 60 minutes in each full degree. Now, it's a little bit unfortunate that the unit is called a minute. It has nothing to do with time, okay? It is 1 full degree is equal to 60 minutes. Now, what I do like about the way the New York State map is drawn, halfway between each full degree, and I see it here, halfway between my 42 degrees north and 43 degrees north, there's another little tick mark. And that's going to tell me I'm halfway through that count of 60 minutes. This would actually then represent 42 degrees, 30 minutes north. And you'll find that halfway through tick mark, okay, in between every full degree. And not just on your latitude scale, but also on your longitude scale. For example, here is 75 degrees west longitude. Here is 76 degrees west longitude. Here's my little tick mark that tells me I'm halfway between the 75 and the 76 degrees. That would be, and I'll write it up here for ease, 75 degrees, 30 minutes west. So, using both full degrees and minutes, we can be much more precise at identifying specific locations found within the state. So maybe the skill that we focus in on in our first visit to this map is not just recognizing the shape of the state, recognizing the cities, the waterways, the rivers, but also practicing a little bit in terms of latitude and longitude. So let us take a look, and I think I can get this out of here. Okay, good. Let's take a look at some examples. So how about we look at these 3 examples, beginning with Slide Mountain. Okay. First trick, find Slide Mountain. Okay, and as you look around, and you will get more familiar with this as time goes by, Slide Mountain is right here. Now, there happens to be a little triangle representing the exact location of Slide Mountain. If it were a city, there is a dot. So I'm going to focus right there on where that Slide Mountain triangle is. Happens to be exactly on my 42-degree north latitude line. But remember, you're asked to do this in full degrees and minutes, so that would mean you would have to write 42 degrees 00 minutes north. Okay, even though there are no minutes, you have to write the 00. And let's take a look at where that places in terms of longitude. Because now it's not 74 degrees, it's not 75 degrees west, it's in between. And if I look for my tick mark, which is just about here, it's looking very, very close to that halfway mark. So there might be a little bit of play here if you wanted to call it 74 degrees 25 minutes west, or even 74 degrees maybe 30 minutes west. I think you'd be in fine shape. So I'm going to write 74 degrees 25 minutes west. Okay? And remember, latitude is always placed before longitude. Let's take a look at Buffalo. Hunt it down, Buffalo right here. And the dot that represents the exact location of Buffalo is right there. All right. Now, in terms of our latitude, here's the 43 degrees. There's 42. So as I look at this scale, it is a lot more than 42, but not yet 43 full degrees. Here's halfway through, right? That's my 30-minute mark. So as I look at this, I'm going to estimate 42 degrees 50 minutes north. Remember, 60 would click me into the next full degree, would click me over from 42 to 43 degrees. It's not that, so I'm going to go with 42 degrees 50 minutes north. And let's take a look at its longitude. Now, as we look at this, this is 78 degrees west. Here's 79 degrees west. My Buffalo location is in between 78 and something. Halfway through, here's my little tick mark. And it's clearly more than halfway, much closer to the 79 degrees. So again, I think I'm going to estimate 78 degrees and 50 minutes west. 78 degrees 50 minutes west. One more to go. Let's try Mount Marcy. Mount Marcy is up here in the Adirondacks. Again, now this one has a triangle to mark that exact location. Happens to be on a line of longitude. That'll make our job for longitude easier. But let's start with latitude. Here's our 44 degrees north. Here's 45. Now it's not 44 degrees. It's a little bit more, but nowhere near halfway through. So what's a little bit? How about we go 44 degrees 05, 5 minutes north. Okay, just to indicate it's a little bit off that full degree. 44 degrees 05, not just 5, 05. 05 minutes north. Okay, and our longitude for Mount Marcy up here, right there on that 74 degree west line, but remember it's degrees and minutes, So we're going to say 74 degrees 00 minutes west. Again, just a reminder, for New York, as in all the United States, all of our latitude values are north because we're north of the equator. All of our longitude values are west because we are west of the prime meridian. All right, that's a good beginning for this map, which remember you will see in this format, but just lay a straight edge down and you'll be in good shape. Okay, that's it.